Hi everyone, welcome back. Today, quick revision for work, energy, and power. So we are going to start now without wasting time. First of all, as you know, we are starting with definitions. So work, power, work energy theorem, conservative force, non-conservative force, conservation of mechanical energy, and mechanical energy. All definitions here. Please study, please try to memorize. Nothing to do, we should know them all. All right, let's continue with next one. How we are going to calculate work? Work is the product of force and displacement in the direction of force. So that one is giving you cos. We are using cos for this question, for just calculating work. Work is a scalar quantity. Unit of work is joules, you know. And then if the angle is 180 degrees, the work is negative. So let's explain that now. Let's see. As you see, we have only apply force here. Let's say F apply. F apply, work done by apply force equals F apply times delta x times cos angle. But if we say object, object is moving this way. Okay, if object is moving this way, as you see, F apply and direction of motion same. If you have two vectors, same direction, let's draw like this. As you see, angle between these two is 0. So work done by apply force is equal to F applied times delta x times cos 0 we are using. Why 0? Because there is no angle between these two vectors. So you can say just positive 1. This is positive 1. You are using cos 0. But let's say we have friction force on the surface. You have friction force, but now, as you see, opposite direction of motion. So what is work done by friction force? Friction force equals work done by friction force is equal to friction force times delta x times cos 180 degrees. Why 180? Because direction of motion vector this way and friction force vector this way, F, and let's say acceleration or velocity is fine, direction of motion showing. As you see, angle between these two is 180. And then we know cos 180 is negative 1. Because of that, you are getting negative. Work is negative. I hope it's okay now. But if you have other apply force, if you apply force with angle, let's continue. Today we are tired. Huh? Okay, so total work done, net work. So we are going to work energy theorem and other things now. You have these forces. Okay, so let's try to get work net work for each force. Work done by applied force plus work done by normal force plus work done by friction force plus work done by gravitational force. Work done by normal force and work done by gravitational force will be 0. You are going to say, you are going to ask why? Because direction of motion, if this way or other way, it's fine. Direction of motion, let's use to the right. And gravitational force going down. Angle between these two is what? 90 degrees. So F gravitational force times delta x times cos 90 is 0 because we know cos 90 equals 0. Normal force also same stuff. So direction of motion this way, normal force going up. As you see, angle between these two is 90 and making 0. So we don't need to calculate normal force work done by and gravitational force. We don't need because of 90 cos 90 making 0. I hope it's okay. So to get work net, only parallel one we are using. Work net equals work F apply plus work done by friction force. But F apply with angle also. Let's use alpha, another angle here. So if you have angle with apply force, so you are using only F apply parallel. So it means we are using F apply times what we have cos alpha. Okay, F apply times cos alpha we are using. Let's write nice. F applied times cos alpha. I'm using, let's write here, F apply parallel is equal to F applied times cos alpha. Okay, this cos is different one, all right? So this, we are gonna have two cos. So work done by applied force for parallel one, as you see, work, okay, it's here. So how I'm gonna write, let's continue from this point. A work done by applied force plus work done by friction force is equal to F applied times cos alpha. You are writing component first, times delta x times cos 0. All right, so first of all, you are getting F applied perpendicular, so F applied parallel, and then times by delta x, and then times by cos 0, and plus friction force times delta x times cos 180. All right, so just remember, if direction of force and direction of motion same, you are using cos 0. But if you have, you know, angle and components, you must just get a parallel first, and then times by delta x, and then times by cos 0. All right, so, and another option to calculate net work, you can use mechanics. Firstly, you can get net force. What's our net force? F net equals F applied parallel minus friction force. What's F applied parallel? F applied parallel is equal to F applied times cos alpha. Okay, F applied times cos alpha minus friction force. This is our net force. And then to get net work, you are writing F applied times cos alpha minus friction force times delta x times cos 0. If opposite direction of motion, F net must be opposite, same direction of, sorry, not opposite, same direction, so cos 0. So this is our work net. All right, what we are doing, so apply force times by distance times by cos 0 if they have same direction. And then for friction force, as you see, I didn't use for friction force because we calculate already F net. All right, straight I'm using F net. For this one, I'm just using F net. F net moving delta x meters. So straight I'm using F net times by delta x and cos 0 degrees. So for friction force, 180. Angle is 180. Okay, let's clear all and let's check one more time. Work net equals work done by applied force plus work done by normal force plus work done by friction force plus work done by gravitational force. But we know normal force and gravitational force work 0 because of 90 degrees, and then work done by applied force, F applied times delta x times cos 0, and then for friction force, cos 180. I hope it's okay. Let's continue with next one. Let's see what else we have. Yes, mechanical energy. You know already mechanical energy from, let's see. Okay, something wrong. Let's just try again. All right, let's continue with mechanical energy. Mechanical energy is the sum of the kinetic energy and gravitational potential energy. And kinetic energy of an object is the energy, just energy of motion, we can say, formula is here, and kinetic energy, other formula we can get with momentum. So kinetic energy, energy of motion. Gravitational potential energy, stored energy, m times g times h, depends on height. And energy is the capacity of a body to the work. And mechanical energy is the sum of the kinetic energy and gravitational energy. You know that. Unit of energy, SI unit of energy is joules. So we can carry on. Work energy theorem is another one. Work energy total work or net work, you can say. Net work done on an object is equal to the change in kinetic energy of the object. Work done equals change in kinetic energy. This is our formula. Work net delta EK. When you check past paper questions, we put just some different questions you can see about that. So sometimes they are giving you total, they are giving you force and you are calculating work net work, and then asking you maybe V final, maybe V initial, or the delta EK, change in kinetic energy is given. You can see on your, just on past paper questions, delta EK is given, asking you force, or because work net formula we know, F times delta X times cos 0, or just say angle, so equals this 1 over 2. Okay, let me just do this. So F times delta X times cos 0, or cos angle, let's say. So you are using this equation to get force, or to get delta X, or even the angle they can ask. So the angle 0 or 180 is fine. So maybe this side is given, work net is given, asking you V final, or V final, V initial, even delta EK straight, change in kinetic energy given, asking you delta X or force. Different kind of questions they can ask. And then conservation of energy. Energy cannot be created or destroyed, but maybe transformed from one form to another. And conservation of mechanical energy. The total mechanical energy is an isolated system, remains constant. So mechanical energy total. So what's going on for this kind of questions? Just object changing position, maybe from first position and coming down, and then asking you for first position and second position, what is initial height, final height, most of stuff given, only one unknown, you are calculating. Okay, conservation of mechanical energy, conservation of energy, work energy theorem, everything is here. So let's continue with next one. So work energy theorem I put again here because we have energy principle now, energy theorem, just energy principle. So conservative force and non-conservative force we have. We have two different types of forces. Conservative force, it is defined as a force for which the work done is moving an object between 2 points, is independent of the path taken. So examples, gravitational force, elastic force, just spring, electrostatic force, we can say non-contact forces. All right, non-contact forces, conservative force. And then non-conservative force, contact forces. So now you have friction force, air resistance, tension, apply force. In past papers, sometimes they're asking you what kind of force you have, and then which one is contact force, which one is conservative force, which one is non-conservative force. If they ask you energy principle, just use energy principle. So you must use this formula, work and C, delta EK, delta EP, change in kinetic energy plus change in potential energy. But if they ask work done, work energy theorem using, only work net equals delta EK. So different questions we have, work energy theorem and energy principle. So two different formula, both of them you are having in your formula box. So these are two different formula. Please remember, work energy theorem only change in kinetic energy, energy principle with kinetic energy, change in kinetic energy plus change in potential energy. All right, we have done. Let's continue. Power is last one. Power is the rate at which the work is done or energy expended. So work over time is giving you power. What is the unit of power? Unit of power is the watts. What is the unit of power? Just remember that. Okay, so let's continue with examples now. Let's see our first example. I hope everything is clear about work energy topic. So if the net work done on a moving object is positive, then we can say the kinetic energy of the object, what we can say is zero, has increased, has decreased, has not changed. Has not changed is zero, is same thing. Okay. So, kinetic energy, okay, kinetic energy. Kinetic energy increase, decrease, or same, or zero. What do you think about that? So now you have work net. Net work is positive. Work net positive means your kinetic energy increase, just like this one. So you have V initial, let's say 0, and the velocity increasing, coming down, and then your kinetic energy increasing, because positive means your kinetic energy, your delta EK is positive, because what we know, work energy theorem, so work net is equal to delta EK. So delta EK positive. It means EK final minus EK initial is positive. So EK is more than EK initial. EK final is more than EK initial. So has increased. That's our answer. Is 0? No. Decrease? No. Not change? No. All right. I hope it's clear. So positive means, so positive, if they said positive, direction of motion and that force, same direction. The direction of motion and force, same direction. They are moving to same direction, let's say. And then that time making positive motion. And then kinetic energy increasing. If kinetic energy increasing, your work net work is positive. I hope it's clear. Okay, let's continue with next one. Now another question. They said, okay, this object, what's going on? 75 kg object, initially rest, okay, on the ground, okay, first, and then going up with 0.65 meter per second. Acceleration, okay, with accelerating, all right, we know acceleration. And then no air resistance, okay. Mass is given, 12 meters going up. Draw a labeled free body diagram. As you know, free body diagram, force diagram in mechanics, we know already, right? So you are showing all forces on the object with dot free body diagram, maybe force diagram, as you see, coming back, force diagram, free body diagram. So we can draw, it's easy one. And then what they ask, name the non-conservative force. Okay, non-conservative force. What was the non-conservative force? Contact forces. Contact forces, free friction force, tension force, or apply force, whatever we have here, we can check. And then calculate the work done on the load. So we are going to calculate work done by the gravitational force. So we are calculating work done by the gravitational force, all right. State the work energy theorem, okay, because from our definitions, we should know work energy theorem, so other definitions also, you know, and use the work energy theorem, all right, we are using it now. Work energy theorem, calculate the speed of load. Remember we said they can ask you, changing kinetic energy is given, asking you displacement, changing kinetic energy is given, asking you force. You know, that kind of question. But now, what is given? Work done, you calculate already, you're going to calculate there. And then you are using that work done to calculate speed when it is just height 12 meters. Okay, different calculations, but same formula we are using. Okay, let's see, draw free body diagram. On this object, as you see, what forces we have? Let's check. We have, as you see, we have tension force going up, and then gravitational force going down. If they ask you free body diagram or force diagram, please draw on the system first, and then you can see what kind of forces you have. You have tension force and work, so not work now, gravitational force you have. So you can show you like this. This is our free body diagram. If they ask you force diagram, you can draw object here. Even they accept this, but just don't take risk. So draw like this is much better. You are drawing your objects and showing forces. This is force diagram. But you must label them, all right? So don't forget to label them, just like mechanics topic. Okay, and then name the non-conservative force. As you see, we have tension force here. Non-conservative force is tension force. But if you say apply force, also working, so also accepted. And then, but if they ask you, name the conservative force, what you are going to say? Gravitational force. Non-conservative force, tension force. Calculate the work done on the load by the gravitational force. Okay, this is our formula. Work equals force times delta x times cos something. And then m times g, we have a force, as you see, gravitational force, m times g. M times g times delta x, already 12, we know. And cos 180. Why cos 180? Because, as you see, object is going up. Acceleration, direction going up. And then your gravitational force going down. And angle between these two, 180 degrees. Is it clear? Let's say yes. All right. And then, so you are calculating work done by gravitational force. And then negative, you are getting negative. It means because you are getting negative. And then you can say velocity decreasing. Yeah, opposite direction. Yeah, velocity. Okay, negative. Oh, okay. Because opposite direction. Gravitational force, opposite direction of motion. Gravitational force trying to pull it down. Okay, the opposite direction because of course, negative. And then next one, state work energy theorem. Next question. Work energy theorem definition you should know from our definitions. Please, definition list. Just get it and study, please. Just try to memorize. And next one, use work energy theorem. Okay, what we know work energy theorem, work net equals delta EK. Yes, work F net times delta X times cos angle is equal to 1/2 times M times V final squared. So now they're asking you, right, V final. See, this kind of questions, they're asking too many questions about this. So now what is given? F net is given, delta X is given, cos 0 you are using, because you are using which one now? Cos 0, work done by tension force, acceleration. So net force, you are using net force because net force going up. F net is equal to tension force minus gravitational force, using minus gravitational force. So same direction of acceleration, because of that cos 0 we are using 1/2 M times V final square minus V initial, and then you are getting V final. All right, you are using this way. Different options, of course, you can use. So, but if they ask you use energy principle, what you are going to do? Energy principle, that time you must use work and C equals delta EK plus delta EP. All right, so please remember that also. So different questions, different types of questions they can ask. Please check all other questions on your textbook, all examples. They're all past paper questions. Please try. I think we have done for today. Yes. Thank you very much. See you next lesson. Good luck for all exams.